Hey, Mr. Stride here. Today we're going to talk a little about searching. So, have you ever needed to find something oh, there they are. Find something in your house, or anything for that matter, anywhere you need to look for it? So, a lot of times you would search for things linearly, and oftentimes that's the only way to search for things. But today we're going to learn a faster way. We're going to learn binary search. So linear search, not the best way to do things. It's kind of slow. But sometimes it's the best you can do because you only know so many things. But if you know more about your environment, then there is a much better way to do it. So for example, let's look at a horrible way to search for something. Let's say that you need to do a guessing game. Have you ever seen something like this? I'm thinking of a number between 1 and 10 inclusively. That means includes 1 and 10. Can you guess it? Is it 1 higher, 2 higher, 3 higher, 4 higher, 5 higher, 6 7 higher, 8 higher, 9. Oh, gee, finally. Okay, so binary search. Whoa. Okay, let's say we're going to search for a number. Let's say that one right there. Okay, let's see if we can find that one. How would we do it? Let's do a smarter search for a number. But so far, what we've been doing is we've been searching linearly for a number. We said we were going to search for a number starting there, right? At 12. So if we were to do this linearly, we first look at the very first index. The first index, it's not 1, it's 0. We say, is it there? No, it's not. We come check the second one. There? No, 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 no. Finally! How long did it take us? 13 guesses to get there, okay? We had to look at all of these across the way. Now, normally we don't search for a number like 12 when we know it's 12. What are we actually really trying to solve here? Well, we're really trying to solve the fact that we have an array. An array where the indices are up here at the top that go from 0, and we're going to go out to 19. And the elements or the values are stored down here that start and go all the way across. Now, the cool thing about a linear search is that your array can be in any condition, which means it doesn't matter if the elements are in random order here. If I'm searching for the value of 0, it may be here, it could be here, it could be over here, it could be anywhere. We have no idea where to search. There's no tricky way to find something in an array when it has no order whatsoever. So you would just do a linear search, just as we've done. So we would do a while loop. While the element at our index is not equal to the target, we're going to increment our index. And then we go through. Nice, right? Okay, did you catch it? This has a bug. This would continue to go if our element doesn't exist in our array. So we'd have to do another condition out here to make sure that we don't extend beyond the bounds of our array. But this is just pseudocode, right? We don't need to worry about such silly things here. Are you ready? Ready to go on to the cool, fancy, schmancy binary search? All right, so where's our element? It's going to be at 12. Now for this, we're just going to be searching the indices. We know that there's going to be array elements down here below, or values, okay? So we're just going to say that we know that our value happens to be found at index 12. We don't know that when we start, we just know that as we're talking, okay? So how would we work? Well, the first thing we do when we're playing smart, right, is we want to check the middle. We go to the middle. How do we find the middle? Well, I add up the left to the right, and I divide by 2. 19 plus 0 is 19. Divided by 2 is 9.5. Oh, but we do an integer arithmetic, so we truncate down to 9. So I ask, is it at 9? Well, the answer is squarely no. It's not at 9. So then we're going to search the right-hand side. We get rid of everything on the left, including the area that we just searched at. We know it's not here, so we got rid of all that. Now we have all this remaining, right? So then we take the middle of the next one. What's the middle? It's 10 plus 19. These are our indices. Divided by 2, I hope I did the math right, is 14. Okay, 14 and a half, I know, divided by 2. So I'm going to check here. Is 14 where our target exists? Are we looking for that? The answer is no. Where is it? Well, we say our target is less than that, so we need to search to the left-hand side, right? So we're going to continually divide the space in half. It's not at 14, and we know it's not on the right because our target is less than. So let's get rid of that. Again, we don't search at 14. We're going to be searching the left-hand side. We need to find the middle. How do we find the middle? Take the indices, the left and the right side of our range. This is our range that we're searching. And we divide that by 2, and we get 11 and a half. So we put our middle, so-called middle, there at 11. Is it there? Still no. So we're going to continue to divide our space in half. We keep going, and we keep going. So once I divide the space in half, I did the middle. 12 plus 13 divided by 2 is 12, and thank goodness I finally found it. How long did that take us? Well, we found it in just 4 guesses. With that, it seemed like a lot because I kept sliding and talking and doing all this, but it was really only 4 guesses. We searched an array of 20 elements, and we found our target in just 4 guesses, way less than 13. But we had to have our array sorted, right? When our array is sorted. So how do we do this? Well, we need to make sure that we have an array to do more like real life. So if we had an array like this, would it work? I already gave away the answer. You guys are so fast. No, this won't work, okay? I can't do a binary search on an array that's not sorted. This thing has to be sorted in order for this binary search algorithm to work. So let's sort it. All right. For the astute reader, those weren't the same numbers. All right. But now I have these numbers in here, in this array, and these are sorted. And we're going to find something. I'm going to look for 41. I don't know where it is in this array, okay? I'm going to look for 41. So how do I find it? Well, first thing I need to do, right, is I'm going to find the middle. So I'm going to say, hey, I'm going to check my index, and I make that the middle of my range. Then, while that element in the middle is not my target, then I know that my target's either going to be on the left or on the right. If my target's on the right-hand side because it's larger than our guess, it's larger than the element at index, then I'm going to make the index be the middle of our right-hand side. Of course, I have to change the range as well, right? If our target is less than, then I'm going to make index the middle of the left-hand side. And the left-hand side and the right-hand side keep on changing. So that's our pseudocode. We need to find the middle of what's remaining. So we need to have the left and the right. How would we do this? Oh, I forgot that bug. What if the element's not found? Well, we need to make sure that we handle that case. And we're not going to do that right now. I'll leave that to the reader. Okay, let's write some code. How are we going to do this? We're going to get rid of that pseudocode. It's gone already. I can't see it. So let's start with our prototype. It's a binary search algorithm, okay? It's going to return the index of the element found. I'm going to pass in an array. In this case, we're doing integers, okay? So up here at the top, again, these are only the indices. Down here and below are actually the values in our array. I'm going to be looking for something with this value. This is the target value I'm looking for. So the first thing I need to do is I need to find the middle, right? So I'm going to say that the left-hand side is equal to 0. And the right-hand side is going to go all the way over here. My length of my array is 20, so I'm going to subtract 1. My middle, clearly, just add up the left and the right, and I get there. Now, next in our pseudocode was to do a while loop. So while our array, the middle element, is not equal to our target, we're going to keep on searching. What do? Well, it's not the element. I need to find out where the target landed. Is it on the left or is it on the right? If it's on the left, what do I do? Did you figure it out? I got to make my right-hand side be where the middle was, -1. And if it's on the left, then I make the left-hand side in the middle +1. And I just keep going until I'm done. Oh, of course, I need to update my middle. You got it? You think you're done? Mr. Stride, you went a little fast through that. I didn't quite understand. Hey, that's okay. Let's walk through it better, okay? We already wrote the code. So let's walk through it. I'm going to search for the element here at 12. This green arrow is going to be my left. This black arrow is going to be my right. Okay, so I started at 0 and at 19. And I need to input the middle. Where is that going to be? As we know, it's going to be at 9. Okay, so the gray arrow is going to be my middle. Is that my element? The answer is no. Where is my target? My target is on the right-hand side. So the target is not less than. So I'm going to take my left. I'm going to bring this all the way over to the right-hand side. So now I'm searching the right-hand side of my array. My right stayed the same. My middle went to the new middle of my left and my right. I'm going to loop back up. Is my middle at my target? And the answer is no. My target is on the left-hand side, so I'm going to take the right, which is my black. I'm going to move it to my middle, -1. Okay, continually dividing the space. So I'm going to move my right to the middle, -1. I'm going to update my middle to be right here at 11. I check that space again. Is that my target? The answer is no. I go into my if. Is my target less than? No, it's greater than. So I'm going to make my left be my middle +1. This is my left. It's going to be middle +1. Then my new middle goes right up to it. So when I check, my middle element is my target. I found it. Yay! Now, if you notice before, we had this condition. What if we didn't find it? What do we do? What if our target wasn't present at all? What would we have done? What should we do? Well, we would look over at 13, right? As it wasn't at 12, it must be on the right-hand side. We'd look, and if it's not there, then our right goes to the left of left, and our left is right of right. Oh my gosh. Green was our left, right? Our black was our right, right? What it's saying is that this arrow is on the wrong side of this arrow, okay? I'm on the wrong side of right. This one's on the wrong side of left. Or you could say I'm on the right side of right, which doesn't make any sense at all. But once we get to this condition, we know that we didn't find it. So then we can go to our pseudocode and we can update our code so that we end in the right time. So we would say we're going to keep searching while we haven't found it, and the left-hand side is less than or equal to right. It's important to get it that it's also equal to, because in our code right here, once we update left to be equal to the right, the left and right can be equal and the middle will be equal. It could have been found at 13. In this case, it wasn't, and it jumped over. So once we get this condition, we exit. What should we return? Well, a lot of people will return negative number, like -1. Clearly, an index isn't at -1 because it has to be from 0 on up. But what can we do? What we generally do is something like this. Sorry, I scrunched it all together. It's right down here. It's if a left is greater than right, that means we didn't find it. Then I'm going to return negative left -1. Otherwise, I did find it and returned middle. How does that make any sense whatsoever? Well, what we do is we're going to do a trick. We're going to encode the index for the intended location of the unfound target. That means if I was looking for something and I didn't find it anywhere in here, where would it belong? Where should it go? Should it go here at 0? Or should it go here at 1? Like if I were to insert it, would it go there? What about if I were to insert it further? So what we do is we make especially encoded values that if it should belong at 0, and I would push everything to the right, then I would return the value -1. And if it should belong at the index 1, where this would stay the same, and everything here gets pushed to the right, then I return -2. And if it belongs here at 2, at index 2, 0 and 1 would stay the same. I'm going to push this item all the way over, and I would return the index -3, and so on and so on. So if it belonged at the very end, in other words, it was the largest value of anything already in the array, then I would take the value of the length of the array, take the negative of that, and subtract 1. So in this case, our array is 20. Negative of that, subtract 1 gives us 21. So if it belongs at the very end, I would return -21. Does that work? Well, let's say that we were expecting it here at 12. We were expecting the value, we were searching for 40, okay? 40 would fit right here, yes? 40 would fit right here. We would want to return 13. We would hit the case where our left was on the right side of right, or is on the wrong side of right. Or right is, never mind, you get it. It's so confusing. When I hit this condition, I would exit my loop. So I'd have all my code, I exited down. This tells me whether or not I found my target or not. If left is greater than right, target's not found, negative left minus 1. So here is left at 12, negative 12 minus 1 is 13. Yes, that totally works. But I like to check my boundary conditions. I have my 0 and I have my top part up there. Let's check that. All right, let's say I was searching for 1, which isn't in the array. That would belong at the first element, or at index 0. In that case, I would end up with my left and right arrows like this, okay? So my left is greater than right. Left is fixed at 0. So if I take negative left, it still gives me 0. Minus 1, yes, that is correct as well. Hey, we've satisfied 2 conditions so far. Let's see if we can get the third one. So let's say I was looking for the value 71. That would be all the way out here. It's not in the array. I would want to return -21. My left and right would look like this after running through the code. My left is greater than right. When I return negative left, this would be 20 minus 1, -21. I totally found it. Oh my gosh, I found it. So we have our code. This is the case after our loops, and then we have our while loop that goes through. Now, in the future, we'll learn how to do this recursively. Oh, my favorite subject. It's so amazing. But for now, what we have is a great way to quickly search for a number or a value in a sorted array. And we found how to return the value when it's not found in the array. So that way you can insert it in or know where to look. Pretty cool stuff. Hope you're enjoying it.